Let's discuss question number 27 from test sets. This is from vibration theory of machines. Okay, so what is given? A woman of mass 55 kg stands in a center of elastic board supported at ends causing mid-span deflection. Okay, so you have a beam, okay, sort of a beam, and simply supported. The woman is standing. Okay, let's model the woman with just a straight line. Okay, so now because of this, the mid-span deflection in equilibrium is something. This is delta. Okay, so now because this is not rigid, it is elastic board, so obviously it will deflect something. So at this point I can model the beam as a spring. So this is the spring with K. So when a moment stands, it deflects by delta. So if you do a force balance, the weight mg is basically equal to K delta. Basically I am assuming that the beam behaves as a spring at a point where the moment is standing. So with respect to that, this is mg K delta. Delta is given the deflection at equilibrium and g is given, mass is given. So K I can easily get. K is mg by delta. Okay, and as I have modeled it with a single spring, now the natural frequency, that is what is asked, the natural frequency neglecting the mass of the board. So it's like it's a massless spring and you want to find out the frequency of vibration. So the frequency of vibration is 1 by 2 pi root K by m, the spring stiffness by mass. Okay, so K by m from this comes from this formula as g by delta. So let's see on what are the parameters it given. G is 9.81, delta is 22 mm, so we are doing in the problem in meters, so 0.022 meters. So this calculation, when I calculate this, comes out close to 3.36 Hz. Okay, so the answer is B, 3.36 Hz. Okay, so only thing is always the beams, okay, if it is given as massless and if it is given as elastic, consider the beam as a spring. In all these vibration problems, consider the beam as a spring at the point of loading. So here the point of loading is center, and so then it becomes a very simple problem. Okay, thank you.